So now we begin to talk about plate tectonics. And the way we talk about it is we're first going to dig into the earth, meaning that we're going to talk about the different layers of the earth. So one way that we're going to categorize the layers of the earth are by composition. What is composition? Means what something is made up of. So you are composed of organs, blood, bones, right? All of those things together make up you. The earth is made up of different layers, and each of those layers are made up of certain distinct different types of materials. So that's what we're going to be focusing on now as we categorize these different layers. What is it made up of? So first we talk about the crust. It's the outermost layer. There are two types of it. The first type we're going to focus on is called continental crust. Of course, it should be obvious. This is what the continents are made out of, right? Hence continental. It's considered to be all the land that's above the oceans. Even if it's not part of like one of the major continents, like if it's an island, it's still considered to be continental crust. Now, the uppermost layer of the continental crust is mostly made out of something called sedimentary rock, which we'll talk about later in the rock cycle unit. However, the majority of the chunk of it, the most of the continental crust is actually made out of a type of rock called granite. Granite is a very important igneous rock. You definitely don't want to take it for granted. Sorry about that. So crust is the outermost layer on the very top, right? It's made out of granite. Now, then we're not considering all the water there, right? Like when we think of the different spheres that make up the Earth, you have the atmosphere, which is all the water on Earth. Then you have, the atmosphere is all the gas on Earth. Then you have the hydrosphere, all the water that's on Earth. Then you get to like the rock sphere, all the rock on Earth. So imagine that there's no water. And if you were to do that, it looks a little bit like this. If you were to take all of the water, this is all the salt water that's on Earth. This smaller bubble right there is all of the fresh water on Earth, and this smaller one over there is all of the fresh water that we have access to. Now, as you remove all of that water from Earth, what's left is you can now see the oceanic crust that's underneath. The oceanic crust looks different than the continental crust because it is different. It's actually made out of primarily something called basalt or basalt. It's not actually made out of salt. It just sounds like salt. And it's all the land underneath the ocean. It is a volcanic rock that comes from underwater volcanoes that trickle out the slow moving volcanic rock, and then it cools and hardens because that water at the bottom of the ocean is very cold. So it instantly comes into contact with that cold, and it just turns it into solid rock. This is an awesome video. I'm going to highly recommend that you watch. How deep have humans dug? And it talks a little bit about I believe it's called the Kola super deep borehole that exists in Russia, which is the deepest that we've ever dug. Basically, the deepest we've ever dug is only to a fraction of the crust. So even though the crust is by far the thinnest layer of all the layers on Earth, we still have barely gotten anywhere through it. And the best of our knowledge, what happens is that the drills get so hot that they start to melt when you get to a certain point, and you can't drill through liquid rock. So we may never be able to go any deeper than we did. So that could be a possibility. We don't know. Let's talk about the mantle. The mantle is located, it's the big one right over there. There's like this nesting doll situation going on here. The mantle is located between the crust and the core. Here's the crust. There's the combined core right over there. Now, again, what is it made out of mostly? There's going to be lots of different materials inside of it. But one of them is going to be olivine, which is a mixture of iron and magnesium. Now, olivine has this nice green color when it's cool and hardened. But of course, the mantle is not like a hard, solid rock, like one solid rock. It is this very slow moving rock that has both properties of being a liquid and a solid. And so it looks molten. It looks like reddish, or like almost like lava would look. So that's the magma that's underneath there, the way it flows. So that would be its form there. There's another picture of the olivine when it cools and hardens in a certain way. Now, the core that's located underneath there, notice they're all made out of different things. We have granite and basalt, we have olivine, and now the core is the densest of all the materials. It is iron and nickel. So when you think the entire Earth used to, once upon a time, be just this huge magma ball, basically, and there weren't distinct layers yet. and then the heaviest materials, called the iron, sink down to the bottom. And then that formed the iron core. That was referred to as the iron catastrophe when that happened. And that is what differentiated the different layers there and caused them to separate from themselves. Now, when you take a look here, this is if there was like a giant that could just pick up one of the plates and rip it out of the ground, it would sort of look like this. This is the South American plate. Notice that the plates are made up of both the continental crust, which is on the far left, and the oceanic crust, which is on the far right. Right? So it's not just the continent, it's all of that makes up this one plate. Here's the thing, though. You can see that the oceanic crust is much thinner on the right side than on the left side. It's much thicker over there. So continental crust is going to be thicker, and it's actually going to be less dense. The oceanic crust is much thinner and denser, and that's why it sinks down to the bottom relative to the continental crust over here. All right, and all of that rests on top of the mantle right over here. So the tectonic plates are a mixture of both the mantle, the upper part of the mantle, and the crust, both types of crust. If you look over here, this is just an interesting thing that I thought. When you take Mars, right, it is actually only 11%, or about 1/10 of the mass, like almost like the weight, I guess you would argue, of the Earth. So when you look at the core has 33% of the Earth's mass. So even though they might be sort of similar in size, the core is much denser because it has more of that heavy material there. Just one way to think about it. So if you add up the core and the mantle together, that equals just about 100%. And you're like, well, hold on, what about the crust? So yeah, everything that we exist on is only less than 1% of the actual mass of the Earth.